Hello everyone. Today I'm going to discuss gravitation, escape velocity, and Kepler's law of motion. Let's start with gravitation. The universal law of gravitation is given by the Sir Isaac Newton. Introduction. An object changes its speed or direction of motion only when a force is applied on it. In this figure, a person pushing an object, okay, and the object is moving in rightward direction. This is the direction of the motion. And in this figure, if we applied force, there we produce acceleration. So there is a relation between force and acceleration. So here a tennis player hits a ball and see the ball is moving very fast and its direction of motion is also changing. Where do we always fall? Why is it that when we jump, we always land on the earth and do not remain suspended or move upward? What makes us to fall on the earth always? So there is always some force acting on us that guides our direction of falling. No matter from where ever we jump or we drop objects from anywhere, they will always fall towards the earth. But there is a particular limit also here. What makes the apple to always fall on the earth? Basically, this course is raised by the Sir Isaac Newton. So it was Isaac Newton who posed this question and answered it. Newton stated that all objects attract each other along the line joining their centers. Every object in the universe attracts every other object towards itself. So this force with which the two objects attract each other is called the force of gravitation. The force of gravitation acts even if there is nothing connecting the two objects. So here is the figure, object M1 and M2, they are separated at a distance r. Then there will be a particular force between these two objects, which is denoted by Fg. So we know that force is a vector quantity, that's why there is a particular direction, but the amount of the force between M1 and M2 are same, but the direction of the force on M1 and direction of the force on M2 due to other object are not same direction, okay, but magnitude are same. The directions are just different. The universal law of gravitation. Newton did not stop after proposing that a force of gravitation exists. He expressed the law in a clear and precise language, the language of mathematics. The universal law of gravitation states that any 2-point particles with masses m1 and m2 attract each other by a force whose magnitude is directly proportional to the product of the two masses, that is m1 m2. If we consider masses are m1 and m2, so m1 into m2 gives the product of masses and inversely proportional to the square of the distance r between them. So here we consider the distance between m1 and m2 is r. You can also consider the distance is d or particular other thing. Okay, the direction of the force is along the line joining the two masses. So in the mathematical form, the law can be represented as shown in this figure. So F equal to G m1 m2 divided by r square. So here G is the universal gravitational constant. Okay, and figure shows two objects with mass m1 and m2 are separated at a distance r. Then there will be a force between these two masses. This is F equal to G m1 m2 divided by r square. In this expression, there is a constant G. So G is a gravitational constant. It does not depend on the value of masses or the distance between the masses. the constant g will remain the same for any two objects anywhere in the universe. And the value of the g is 6.6734 into 10 to the power minus 11 Newton meter square per kg square. So this is a constant value. Now, use of gravitation. It is the gravitational force that keep everything at its place. Otherwise, we would have been floating in the air. So it is due to gravitation that we are walking on the earth. So another use is here. It also keeps the earth, sun, and other celestial bodies at their right places. And here is the another use. It is responsible for many natural phenomena on the earth, like tides and orbiting of moon around the earth. Now let's solve a problem related to this topic. So two friends, they are separated at a distance 2 meter, and the masses of one friend is 70 kg and another friend is 86 kg. And from this information, just calculate the force between these two objects. Okay, so here we can easily calculate the force between these two friends. So if we apply Newton's law of gravitation, F equal to G m1 m2 divided by r square, which is equal to 6.67 into 10 to the power minus 11 into 70 into 86 divided by 2 square is equal to 1 into 10 to the power minus 7 Newton. So the force between these two friends is 1 into 10 to the power minus 7 Newton. But if specifically there is a question, say find out the force on 70 kg friend, then the direction of the force need to be mentioned or need to be drawn here. Okay,